Hello everyone, Yvonne here with DevWidgets, and we are on episode 4 of our series of creating an event microservice. Today we are going to be working on our Dynamodb configuration. All right, welcome back. So we have done a lot of things over the last couple episodes. We made a plan. We created a skeleton microservice. We then went and integrated Spring Boot into our application. And now today we are going to be working on configuring DynamoDB. All right, so let's again look at our chart, look at what we are trying to aim towards, and then build our checklist of what we're going to do today. Okay, so my slightly messy desk, there's a lot of cables and things sticking around. Apologies for that. Let's focus right here. Okay, so we are building a microservice that takes in APIs. Those APIs are then going to go get information from DynamoDB. We have built our API gateway side of the fence. We have built our Lambda function that does some level of stubbing. Today we are getting rid of that stubbing and we are going to actually integrate with DynamoDB. All right, so we have looked at our hexagonal architecture that we're sort of working towards. Not sort of, we are working towards it. And we have built our controller. We have built our application layer. We don't have any adapters to any third-party applications, so we can ignore that right now. And we have, I mentioned already, our application service layer, but our application service layer was not communicating to our domain layer, which communicates to our DynamoDB table. And that's what we're going to be working on today. So we're going to start working backwards. We'll create our DynamoDB table in our CloudFormation template. We will then work on our repros that are going to be able to read that data from DynamoDB, convert it into a Java object that we can read, and then turn around and return it to our application layer. So let's go over the steps that it takes to be able to do that, and then we'll get to it. All right, so for step 1, let's see. We need to, for our DynamoDB table I mentioned, let's say DynamoDB table. All right, for our DynamoDB table, we need to work on our CloudFormation, right? And we need to actually add that table and what it may look like. So CloudFormation. We then need to go and let's create our model in our application. And once we have our model in place, then we can create our repo service layer, service. And once we have our repo and our service completed, we can then go into our application. And we can hook it up. Our repo service. Okay, so once we have CloudFormation, once we have the model and the repo service configured, then we have hooked up our application layer to that. We should be in business. We should be able to go ahead and jump over to Postman or curl or whatever your tool of choice is, Postman, and test it out and see our integration in action. So here's our high level. This is what we're working towards. I'm going to drop this off to the side while we do our development work, make sure I don't miss anything, and then we will review this at the end and make sure we achieved what we aimed to do. All right, let's do this. For our first task, let's create our DynamoDB table. So here's our CloudFormation template where we left off last time. Basically, we have a serverless application or function, I should say, and we have the API greedy proxy configured to call our function. Of course, as you remember where we left it off last time, it was basically just returning stub data. So let's go in and add our table. So the resource that we create for a table, it is, let's see, let's give it a name first. So event functions, let's just copy this, go here and say events table, or let's be specific, Dynamodb table. Okay, and so the type is this, AWS serverless, and then simple table. And so what are our properties? We need to define what our primary key is. So for now, our primary key is going to be an ID. And the type is string. Then we're going to do our provisioned through, can I spell through? Oh my goodness. THROUGH. Throughput. Capital lowercase. I'm looking at the documentation here and it is lowercase. I probably should have just copied that considering how great I am at spelling. Actually, I am going to copy that considering how great I am at spelling, and I will talk through it just to explain what we did. Okay, so provision throughput. This is basically saying at all times, I need you to be able to handle reading 5 concurrent units at a given time. And so the way to calculate those units, you definitely have to pay attention to your object size and determine how many you really need. Depending on how big your object size is, maybe it consumes 2 units for one read, one actual read. So that's something when you go to configure your application, you kind of have to do the math there and figure out how many you need. Our event payload is going to be pretty teeny tiny. Obviously, this is also a tutorial, so we don't really have to worry as much about capacity at this point in time. Once you kind of go into fine tuning for production, then yes, you kind of want to pay attention to this, or maybe even add in some dynamic auto scaling in there as well. All right, so same thing for write. So read and write, we're gonna just default it to 5. Let's give our table a name. So table name is, oops, not an object. So let's just call it events. Let's not complicate our lives. There's jokes that 90% of or 80% of development is finding a good name for your variable. I will neither confirm or deny that that is true, but for now, let's keep it simple. Okay, and so I like to keep these tags on all my resources. It just helps me, oh, that didn't line up right. It helps me determine billing and that sort of thing. Okay, that lined up good. Okay, so next we are going to create a domain layer in our nice little bounded context. So let's go to new package and we're going to call this domain. And within the domain layer, we're going to need a couple different things. We're going to need our model. Our model defines, what exactly our payload looks like. It has those POJOs necessary for that. There may also be some converters. For example, we're using offset date time. We need to convert that into a string so that it can get written to DynamoDB table and then outputted and converted into the right object in our Java class. And that's the bulk of our Dynamo, of our model package. So let's start doing that now. So new, let's say Java class, and we're going to call this model, and we are going to create event. All right, so we're going to have to add a couple annotations here so that we can tell the DynamoDB SDK that we're using what table we're actually working off of. So the first thing, DynamoDB, oh wait, we forgot something. So I need to add our dependencies. And at the time of development, this is the version number that we are going to use. Let's update Gradle so that it can download that for us. Once that's done, let's pop over here and let's try that again. Dynamo, no, table, copy and paste, table, there we go, table name, events, right? Is that what we did? Let's make sure. Again, I'm not very good at the whole spelling business and keeping things consistent. So we confirmed its table name. I did a good old copy and paste. And so what are the objects we need? So we need attributes, not objects, attributes. So string, we need an ID, private. We need a description. And we need what? Our date. So offset date time, date. All right, so let's generate our getters and setters for each one of these. Oops, cancel. I don't know what I pressed, but it's not what I wanted. Okay, so we have, I don't know what that is, remove. That's probably what I clicked, and I didn't mean to. We have our get ID, set ID, get description, set description, get date, set our date, right? But we need to be able to tell Dynamodb which attribute it actually is in the table, right? So again, we're going to add more annotations. We also need to tell it what is our primary key. And the way Dynamodb works is there's a hash key and a range key depending on what you need. For this use case, is very simple. We're only going to have a hash key. So let's add that first. So hash key, think of it again as your primary key. So Dynamodb hash key, and let's tell it the name, which is going to be ID. And I want to cheat here. I don't want to have to manage what the right is, or the next ID available is. So I'm going to do Dynamodb auto-generated key. So it will handle that for me. All right, let's go down to our description. So Dynamodb attribute. And then is it name? Oh, here, attribute name equals description. Woohoo. Same thing. I'm just going to copy this. And we're going to say dates. But here, remember, I just mentioned earlier, this is a little tricky. We actually need to have some help converting that from a string in DynamoDB to an offset date time in Java. So we create what's called a converter. All right, so let's see if I get this right. DynamoDB type converter. And let's see. Okay, let's create it first. So model, new Java class. And I'm going to keep this clean and say convert dot offset date time converter. Okay, and so this needs to, what did I say? Implements Dynamodb. Forgot what I said. Type converter. So this gets parameterized, offset date time, implement methods. So no, that's not right. Okay, let me do what I think I have to do and figure out what I messed up later. So let's go override, and then it's public string convert offset date time. And then we convert that into a string. So offset date time to string. So nothing complicated, right? Then over here we have override public. And this one is the one that goes back to it. And so on convert and then this returns offset date time dot parse object. I don't know what I did. Oh, converter. See, I told you, spelling is a problem. Okay. All right, so we have offset date time converter. We have our convert and our unconvert. So this will give us our switch back and forth. Nothing very complicated, but now let's go back to our events and we are going to annotate it with that converter. So this is where I flip things around. So where's our date here? So we need to do at Dynamodb type converted. Here we go. And now we pass our converter. So converter equals offset date time converter. That class. Okay, so that is our converter. And I believe that is it. I'm looking at my notes at the same time, but basically we have our date. We have a converter to go from string to date. We have our description. We gave it an attribute name. We have our ID and we gave it DynamoDB auto generated ID. Attribute name, we gave it our table, and that is it. Okay, let us continue. Let's see. So now that we have our converter, let's actually work on reading and how we're going to read that. So I am going to go here and do domain dot, and we're going to write our repository or the classes to support our repository. Repository. I made a mistake. Cancel and delete. Let's try that one more time. So events, new, oh, come on. One more time. Java class. Now we are going to go domain dot, there we go, and repository dot, and then it's I event repository interface, enter, add. Let's go and create our implementation, new Java class. It's going to be impl event repository. Impl. I made a mistake. Let's go back here. Period. Impl event repository. Got it. Add. Lovely. Beautiful. And we're gonna say you implements I event repository. Oh, where did that come from? I event repository. There we go. So what is our repository gonna have? Basically we are going to have a get. So event is gonna return our domain model, and then it's gonna be find by ID. I imagine we're gonna have a save, so that's not gonna return, or we can have it return the event that it created. save event, and we are going to have a list event. Not too complicated. Import actually, I'm going to change this. Let's do rename. I'm going to just do get. We're not really doing anything, any different type of searches at this point. We can refactor later on if we want, but it's just get events. Let's keep it consistent and then save. All right. Let's put some breathing room here. Okay. Yeah. Okay, so let's implement methods. Lovely. All right, so now that we have this here, how do we actually connect to DynamoDB, right? This doesn't help us. This is really just how do we make that whole communication. I mean, this is just how our application is going to communicate to our model, right? Or to our domain layer. What we need to actually do is in this info folder, let's create basically a facade for our client. And then we're also going to use to facilitate converting from our objects in DynamoDB into actual Java objects. I'm going to use their DB mapper that comes in that dependency that we added earlier, the SDK DynamoDB dependency. So let's start with our client facade. So let's call that DB client facade. How's that? And I'm going to have an interface and an impl add. So these classes that I'm creating really only matter in context of our repository, right? So I don't need to have anything public that anyone can access to. So I'm just going to have the impl and the interface in the same package. So DB client facade impl. Right? And then we're going to do our mappers too. Right now, this is just a bunch of skeleton classes. So IDB mapper facade. That's also an interface add. And then we're going to go and add our impl, DB mapper facade impl. Add, okay. Mapper facade, let's do the same thing here. Implements IDB client facade and so on. Okay, so what are these classes going to do for us? Our first one, let's do the client. Really, this needs to create a DynamoDB client. So private final, this is what we'll use to communicate. Amazon, there we go. So this is our DB client. And what do we need to be able to create this, right? So public DynamoDB. For now, let's leave this empty. We don't know what we need, right? So looking at AWS documentation, to create this DB client, we are going to use the Amazon. Why doesn't it auto-populate? Oops. Start that again. There we go. Amazon Dynamo DB builder. DynamoDB client. I don't want async. Just plain old client builder. There we go. So we're gonna do standard, and then what else do we gotta give it? With what? Let's do with region. So let's do US East 1, or whatever region is closest to you. You can change that. And I think I'm not going to configure anything else. That's pretty much it. Let me clean this up so it looks a little clearer. All right, and then let's create a getter for this. Create getter. I don't think that is pretty much it. I don't think we need to do anything else. Let's go ahead and create our test for this. Shift Command T, create new test. Let's create our setup for consistency's sake. So private DB client facade impl. Nothing interesting here. And so we just want to make sure at this point assert that it created it, right? So DB client dot get this. So like let's assert not null DB client. Oops. So we should be able to run that. Shouldn't be pretty complicated at all. Let's quickly jump over here. And so this is going to be our mapper. And so what does our mapper do? I briefly mentioned earlier that our mapper helps us convert our objects that are in DynamoDB into actual Java objects. And we don't have to do that whole like object.get column XYZ and put it into our POJOs, our plain old Java objects. And we let this class do it for us. So let's create that. So let's create, public. And looking at the documentation, what do we need? So we need a new DynamoDB mapper. And what do we need to give it? So we can take a look here. So we need to give it our client and then some sort of config. That's the one out of the box. So let's go and add that. So we need our IDB client facade dot get. Oh, did I not add that? Here. All right, so if we look at our client facade, you'll see it added that. Let's go back to our mapper and say get client. Let's see. Dynamo DB mapper config, and let's see if they have a default one or so. Here you go, default. And then to make it clear, like what inputs, well, it doesn't matter. Okay, so we have that. We're not saving it to anything, so let's do that. So we have a DB mapper, and then let's try that again. I want to save it to a field. All right, so DB mapper, and then let's create a getter. And that's pretty much it. Let's not forget to update our interface. So pull it to our interface, and then let's write our test. So again, our test, very simple. Let's just assert that it gives us what we need. So private DB mapper facade. And we need to give it, let's see, private IDB client facade. Let's instantiate that because right now it's null. So client facade equals mock. So idb client facade dot class import Marquito. There we go. And so we are gonna do mapper dot get db mapper. Gonna make sure assert not null. Let's make sure that it actually created something. Let's run that. And so it passed. Again, nothing complicated. We're just making sure that our constructor is doing the work that it needed to do. So let's go back here to our repository. So how do we interact with this? So let's go and add our public constructor. And we are going to need idb mapper. And then so this dot mapper facade equals our parameter mapper facade dot get db mapper, and it's actually just load. And I believe all we have to do is pass in string and what we want it to, what kind of object we want it to cast to. So we want an event. We use our model. Oops. Dot class. And so let's save this to, actually, I don't even need to do that. Let's just do this. Return. You could see that a little clearly. Our save. I think the save would be pretty easy. Let's do that first. So mapper facade dot get db mapper dot save, and then we're just gonna pass in that event. We wanted to return that. So let's do this. I have to double check, but I believe that when you call a save with the whole auto generated, it will automatically stamp because this object is mutable, is not immutable. It will stamp the new ID. I will test that. I'm not entirely sure and get back to you. But let's see. That's pretty much it. We did that. And did we do our get events, our list? Okay, so this one is a little different. Basically, because we want to return all events, there's no filtering. We don't have a range key to be able to filter on or anything like that. I believe, let's start get db mapper dot scan. What kind of class we're scanning for, I believe. And then db scan expression. So we actually we're not gonna do anything interesting here. So I'm just gonna blindly pass a new here. We're not gonna say, okay, where if this column has such and such and so and so. So just return every event that you have in our table. And I believe that is it. So let's go ahead and create our test for this. Shift Command T, create a setup. Let's test all our classes. Add it to Git. And what do we need? Okay, so private, our repository. So repository. So we need to pass it a mapper facade. So we come up here, private IDB. I can't spell private DB mapper, no, I. Mock class import, give you that repository. Okay, so what else do we need? Oh, we have to map. Let's remember. So repository.get event 1, 2, 3. So we have to mock this DB mapper. So let's go back to our test. And so we're going to need it for all of them. So I'm going to do that in my setup method. So when mapper facade dot get DB mapper, then we're going to return, we're going to mock it as well. Dynamodb mapper dot class. Let's store this as a field because I'm assuming we're going to have to do some stubbing in our individual tests. All right, so here, when dynamodb mapper dot load event dot class and 1, 2, 3, then return new event. So when we save this to a variable, we're going to do assert equals our expected event and the event we got back. And again, not that big a deal. So we did that. Let's do the same thing for our, let's do save because save is easier. Let's go here. I'm just going to copy and paste and modify. You can write it one by one, or you can change that around. Okay, so for save, and a past this class we created. We don't need to do anything. Event. And we're just going to assert that it returned exactly what we expected. If we go here quickly, so it calls the mapper facade and then it returns an event. And we can actually assert that this happened. So let's go back. Sorry. Here we go. So we can run this. This is fine and beautiful, I'm sure. We can drop down here and say verify that our DB mapper. Is that the right one? Yeah. Called a save with our objects. So event. Oh wait, no, I'm writing this wrong. So it's comma times, how many times did it call it? And we call save, and that should be it. Run. Okay, so it actually did something, nothing failed. Beautiful, lovely. So events is a little different. So repository.get events. We're gonna save that to a list. So I believe, let's do the mock. I believe I cannot just do a return list. So Dynamodb and then scan and it's event.class. And then what did we pass to it? Oh, it was that expression, right? So we actually have to do equal because we created a new class. We can't, so any, and it was a Dynamodb scan expression dot class. There's no real point in asserting the contents of this because if you remember, there was nothing in it, right? So let's just scan. When we have a call like this, that it has an event class equals the first parameter, and the second parameter is any kind of DynamoDB scan expression. We're going to say then return, and it's a paginated scan list. So mock paginated scan list class. Let's store that. Expected list. And so we can come down here and say assert not null events and assert equals expected and then our returned events. And I believe that's it. Let's try that. All right, so that looks good. Let's clean this up a little bit so it's a little more user-friendly. So the first couple lines is all our mocking that we have to do. The second one is our actual repository call. And then last but not least is our actual assertions. So we should be able to run this whole class. Everything passed. Why don't you like this one? Because we're not using it anywhere, it's just going to be a local variable in our setup class. Okay, so beautiful. Now, one thing I just realized. So we are depending on Spring Boot's dependency injection, but we haven't annotated this in any way to tell it you need to inject this somewhere else. So let's go ahead and add that. Same with our repository. So everybody gets in a component. What happened? What did I mess up? Sorry. Component. Okay, so we will have dependency injection with these three classes. And then, so let's go here to domain new Java class. Let's do our interface first. So it's going to be service that we're creating, and we're going to call it event service repository service because we already have that. So we already have event service in our application layer. So event repository service, which makes me think I should have called that other one event application service, but I didn't. We can always refactor that later. So let's add our implementation, event repository service impl, and let's add this in an impl package, impl.that class. Edit. This is going to implement event repository service. And then I think let's go ahead and get fancy here, and instead of just having plain old boring getters, let's do event, and let's do, oops, okay. Let's do find event by ID, because again, this is our business logic here. We can have, find event by date. We can have find event by, n number of filtering options, right? So string ID event find oh wait, I mixed it up. So let's say find all events. And this one will be a find event by ID. Oh, I totally mixed this up. Goodness gracious. Okay. This is not going to have any parameters right now. Again, in the future, maybe we do have something here. Okay, and then the last one is our save. So save event. And it's going to take an event, and that's pretty much it. So let's add some air here, some breathing room. We're going here. We need to implement those methods. And then how are we going to get this information? So we're going to get it from our repository. So private event repository. Actually, interface. I keep forgetting that today. So event repository. And we're going to add our, this is also a component. Or let's be specific, it's a service. And let's create our public constructor. Event repository impl. We'll take an I event repository. Okay, so here we go. Let's actually do the work. So return repository get events. Ooh, very complicated. Get events and pass in that ID we got. And here, repository dot save event. I bet you're noticing a pattern here, right? Okay, so as homework, I'm going to let you do the unit testing for this. It really isn't going to be too complicated at all. Make final. It's not complicated at all. You're going to have to do some sort of mocking and saying, you know, when you call repository.getEvents, return this object, assert it equals. Really not complicated at all. I believe you can do it. All right, so let's jump ahead. I think we pretty much have all the guts we need. I believe we can go ahead and deploy this. I believe, oh wait, no, sorry, we didn't hook it up. Event service. So our event service is no longer going to return stub data. Instead, which means we'll have to update our tests because our tests are expecting stub data and we're actually going to we're going to mock that repository, that service, repository service. And that's pretty much it. So let's do this. Okay, did we have a constructor? We didn't have a constructor. Okay, so let's add it. Public event service is going to take an I event repository service. Let's do that. And then we're going to do this dot u equals this. Create the field. Lovely. And now we're going to start using it. That's so exciting. And repository, oops. Get find all events. And it's going to give us a list of events. And then we have to do some work to convert that into our DTO objects. We don't want to bleed our domain objects anywhere outside of our service layer. You know, if we wanted to do some refactoring and change that around in our domain layer, we want our REST APIs to still be backwards compatible, and we would do all that massaging and handling here. So I'm going to be creating a new method that goes and takes this and creates all the DTO objects. Okay. Let's see. We're not going to be doing this anymore. So we're going to do something that gives us return. So let's do convert to DTO, data transfer objects. And this is a list. So let's put S here, all events, and let's create this method, create method, convert. So we're going to basically create a new list of event DTO. And then let's cycle through our returned objects. So event, all events, and we create a new event DTO, event DTO. And then because I know that for the get event, I'm gonna have to do some transferring. I'm gonna make a method to convert a single object. So convert DTO and give it the one event and call it a day. So let's create this method. And this one is the one that's actually going to create the new class, event DTO equals new event DTO. Set description, get description. Very complicated. Set date, event DTO dot get date. And then we're going to return event DTO. So this gets added to our list. And then we return it. All right. So this gets deleted. We're going to come here to our get event. And so instead of, let's expand this. So it's going to go to the event repository, find by ID. We're going to save this to a variable. And then we could just do convert to DTO, event by ID, and call it a day. Now, I'm sure you probably noticed that, one second, let's mute that. Okay, I'm sure you probably noticed we're not doing any error handling. We're not making sure that this is not null. We're not going to return the correct HTTP response to the front end to our REST API if that happens. So let's do some of that now. So we got this. And before we convert to DTO, let's make sure this is not empty. So if event by ID equals null, then instead we're going to return an error. So we're going to throw new response status exception, HTTP status of not found. So, and then we can add some nice string here that makes it helpful and say, you know, no event found for found matching ID. Let's do this. And that's pretty much it. Let's do the same thing for our get events. So if all events equals null or it's empty. Again, we want to tell them we didn't find anything. So I could theoretically just copy this and say no events found. Call it a day. So our unit tests are going to fail because we're not mocking anything here. And something is complaining. What is the error? Oh, I have an extra thing here. Okay. Let's clean that up. So one related problem, and it's probably our test. So let's go to our test. And as we see, there's an error here. So we need to add our mocking private on repository service. Let's mock that. Oops. Dot class. So we passed it in. And now we have our service. So this is going to be null, right? Because we're not telling it to return anything, right? Run. We can double check. We got our nice error. We got a 404. And so we need to handle that. So let's do that. We need to go here and mock. So when we call our event repository service, find by ID, and we're gonna pass, let's be smart about this. Let's actually pass it out since we're not doing mocking anymore. And in fact, we should probably add validation, but I'll let you do that as homework. Again, if it breaks, I mean, if the parameter is null, you can turn around and throw an exception. So similar to how we threw an exception here, you can say if ID is null, throw bad request. For example, they didn't supply the information they needed to supply. And again, I'll in our completed project, I'll go ahead and add that so you can see what it should look like. But here it's going to return our, did I stub it here? Create events. I thought I did that somewhere. I like to copy and paste. Here we go. Not copy and paste. Theoretically, I should have this in a shared place that all my tests can access. But for now, let's just do this. And we're going to say, so when you call that, oh wait, no, I can't do that. I need to mock the actual event from our repository. So let's change that and change that and change you. And for consistency's sake, let's just rename this because it's not a data transfer object. Let's come back up here. It's not a DTO. So when it calls our repository, return that stubbed information and assert that it's not null. Run. And that should pass. So same thing, we're going to come back down here. We're going to call this. And in theory, everything should pass once we add the mocking, right? Of course it didn't. Why didn't it pass? Oh, because I didn't change my parameter. Here we go. Let's do that one more time. And that's proof, right, that this when then returns is working, right? So for your homework, go ahead and do the same updates to your unit tests for the events, get events methods, and we'll meet at the end. Run all tests. Everything should be copacetic. We have 13 unit tests, should have pretty decent code coverage. We have upgraded our dependencies to have this new Dynamodb concept. We have updated our template to add this simple table. And let's go ahead and run this. Git. I always miss it. It's at the very bottom. Deploy serverless application. All right, we're going to create a new stack because after each episode, I destroy the stack. So events ms deploy. And so while that's working, I'm going to jump into another window and log in to our tenant, because we're going to have to actually hard code adding in an event. All right, so it is complete. I am not logged in yet though, so give me a minute. Okay, so let's go see what we created. So if we go to Dynamodb and we take a look at our tables, we now have in Northern Virginia, that's USC Swan, a new events table. If we look at item, there is nothing here. So let's create an item. Let's give it a value of 1, 2, 3. I actually like text. So let's do 1, 2, 3. Let's give it a date. Let's give it a description. Okay, here's an offset date time. Then our description. Oh, we need commas here. Comma, comma. Okay. Our description, I'm going to copy it from here. And whatever. Okay. So not exactly the one we've been using, but again, look, we can go in here. We can see it. Text, beautiful, gorgeous. Save. Let us go to Postman. Do I have Postman open? I do not. I do now. It's thinking very hard. So this is the ones that we were working with last time. I need to update the URL. So let's go back to IntelliJ and look at our outputs. So our output, and let's copy this, then go back to Postman. It should be different. It is. Oops. Let's go here, delete all of that. Okay, so V1. And then you saw the ID I gave it was 1, 2, 3. So if we send, starting up our Lambda, this is beautiful, this is great, and it returned 404 not found. Why? If you're paying attention, I had another one of my spelling issues. So event 1, 2, 3. So let's send this. It should be faster now because we don't have a cold start anymore, but of course that is not the case. We got a timeout. I don't know why. Why is it timing out? Let's go look at our... This is actually pretty valuable. Maybe I won't edit out. So it's timing out. Let's go look at our logs because something always happens. And we can take a look here. Today is the 22nd. That is being recorded. And something is happening here that is causing an exception. So I called it a bunch of times, as you can see. Nested exception is not authorized to perform Dynamodb get item on resource. Permissions. Oh yes, I forgot permissions. So we need to add a policy to our Lambda. So policies, statement is a list. So statement. And so what does our statement have? Let's give it an ID so we can remember or understand what it does and not have to look at the nitty gritty. So Dynamodb read policy. And so basically we want to allow, and what actions do we want to allow? We want you to be able to do a get and a scan. So Dynamodb, it's all lowercase, right? Get item, and then Dynamodb, and then we're doing a scan. So scan. And then what resource? Again, least privilege, right? We don't want this Lambda to be able to read all DynamoDB tables, only our specific table. And I am going to copy and paste this because I'm bound to get it wrong. So that's a lot of text. And then let's make sure that this table has the same name. It does not. So here we go. So this is the ARN of our table, our DynamoDB table. Let us deploy one more time. Deploy serverless application. We're going to update that existing stack. It's going to add permissions. And while that's happening, I'm going to go look at my notes and make sure I didn't forget something else because I'm good at that. What? Syntax errors. I don't know what the syntax error was. Maybe the spaces. So deploy serverless application. Deploy. We should be able to hop over Postman. And we should be able to call this same API. What? Oh, haha. Buddy, look at that. And guess what? We can go to here and we can go here and put a S and then we can press enter and look at that. This is so awesome. Okay, well, congratulations. We got here. Let's switch back over to our checklist and make sure we did what we set out to do. All right, we are back. We have finished coding. We are looking now at our chart and we are going to make sure that we did in fact do what we said we were going to do. So we definitely went in and did our cloud formation. We had some mistakes, so we had to come back and do that at the end. We created our model. We added the appropriate annotations that we needed to be able to map to our DynamoDB table and our different attributes in that table. We created our repository and we created our repository service where we get to hide away a lot of business logic. Today there wasn't any, but you can imagine that that could grow and change over time. We then went to our application layer and we hooked it up to the repository and we updated all our unit tests so that that could still run as expected. Lastly, we ran into a little bit of a hookup. We went and fixed up that hiccup and we were then able to jump over into Postman and actually call our API. It's very important. IAM is very key to be able to give your Lambda permission to be able to use your DynamoDB resources or any resources really in AWS. So little hiccup there, but we definitely got where we needed to go and we were able to see it in action. So I hope you had fun today. I hope that you learned something today. I hope that you actually did work along with this, or if you want to, just bookmark it and work on it later, definitely welcome to do that. Obviously, like I mentioned before, or maybe I didn't mention it, I don't remember, but projects are in GitHub, so you can check those out. There's a starting point and an end point that you can work from. Definitely check that out. If you think somebody could learn from this series, please pass it along and share it. Like, subscribe, share, you name it. Definitely do that. That was helpful to get this out to more people. And most importantly, happy coding.